Alright, let's dive into something mind-blowing. Imagine a glass of ice water. Simple, right? But here's the kicker. That glass is a perfect example of something called coexisting phases. Water, in its liquid and solid forms, exists together in harmony. Now, what if I told you this same concept applies to the quantum world, but in ways that are way more complex and fascinating? That's exactly what a team of MIT physicists just uncovered, and it's a game changer for how we understand materials at the quantum level. Here's the deal. They studied a material called erbium tritelluride, and what they found is that its electrons can organize into not one, but two distinct phases simultaneously. Think of it like a quantum checkerboard, where electrons are playing by two different sets of rules at the same time. What makes this really interesting is that these phases aren't just sitting there, they're dynamic. One phase forms gradually, like water turning into vapor, while the other emerges in isolated pockets, almost like ice crystals forming in a tray. This isn't just cool science, it's a clue to how materials can host superconductivity, magnetism, and other exotic properties. Personally, I think this is where things get really exciting. The way these phases emerge tells us something fundamental about how quantum materials behave. The first phase, the dominant one, follows the textbook rules. It reforms smoothly, no surprises there. But the second phase? That's the rebel. It doesn't play by the same rules. Instead of a smooth transition, it forms in pockets that spread out, like a domino effect. This raises a deeper question. Why do some phases follow the rules while others break them? And what does this tell us about the materials that could one day replace silicon in our tech? From my perspective, this study is more than just a scientific curiosity. It's a window into the future of quantum technology. If we can understand how these phases coexist and interact, we might be able to engineer materials with properties we've only dreamed of. Superconductors that work at room temperature? Quantum computers that don't require ultra-cold conditions? These aren't just sci-fi fantasies, they're potential outcomes of this kind of research. One thing that immediately stands out is the method the researchers used. They essentially shook the material with laser pulses and then listened to how the phases responded. It's like hitting a bell and studying the sound waves to understand its structure. What many people don't realize is how ingenious this approach is. By disrupting the system and watching it recover, the team could tease apart the mechanisms behind each phase transition. This isn't just a new discovery, it's a new way of studying quantum materials. If you take a step back and think about it, this research is part of a bigger trend in physics. We are moving from observing phenomena to actively manipulating them, from understanding the what to controlling the how. And that's huge. It's not just about answering questions, it's about opening up entirely new possibilities. In my opinion, this is where the real magic of science happens, when we stop being passive observers and start becoming active creators. So, what does this all mean? Well, for one, it's a reminder that nature is full of surprises, even in the tiniest, most fundamental systems. But more importantly, it's a call to action. If we want to unlock the potential of quantum materials, we need to keep pushing the boundaries of what we know. This study is a step in that direction, and I can't wait to see where it leads. What this really suggests is that the quantum world is even richer and more complex than we imagined. And as we peel back its layers, we are not just learning about electrons and phases, we are learning about the very fabric of reality. So, here's my question for you. What do you think this means for the future of technology? Are we on the brink of a quantum revolution, or is this just another piece of the puzzle? Let me know in the comments. I'd love to hear your thoughts.